Good morning. Welcome to this session of Geometry, Cosmology, Spirituality. Now it's 3:30 in this part of the world where I am. Good afternoon, perhaps, if you're in the States or in South America. I just went to look at the moon, and there's a very slight bit off the top right-hand corner for the lunar eclipse or partial lunar eclipse, which is happening at the moment. Now, in this session, I'm going to look at a particular cosmological ratio to do with planet Earth, which shows itself in the design of the cathedral here in the city of Wells. Now, in the last session, I showed the way in which this diagram shows itself in the design of the cathedral here at Wells, where you have this larger circle is an image of the Earth, whereas the smaller circle is an image of the moon. And this shows itself within the design of the cathedral in the way that the diagram is showing. Now, this diagram was envisioned by someone called John Michell in the early 1970s, or late 60s, early 70s, sometime like that. But it looks as though this diagram was also known and used by the designers of Gothic cathedrals, as well as probably also the designers of the Great Pyramids in Egypt, because that triangle there is what's known as a pyramid triangle. You can look at the last session, session number 23, to get more details on that. Right, here is another view of the cathedral with geometry on it. Now we need to look at the left-hand side, at the nave area, so where you first enter the cathedral, where there's that rectangle with various red lines in it and the diagonal dotted lines. Now this area is also symbolizing the earth. And in this sense, the journey of ascent through the cathedral, the ascent eastwards, actually begins from the earth. Now, I showed this in episodes 12 and 13, but I'm going to go into more detail this time with this cosmological ratio that I mentioned earlier as giving, I suppose, making it an image of the earth. Right, as you can see, the tropics of Cancer and Capricorn, they coincide with the north wall and the south wall of the nave in the cathedral. Now, the reason why this is possible is because it's a particular type of rectangle which is used for the outline of the nave. Now, this particular type of rectangle has very simple dimensions, and it can be seen in the footage of the nave and the amount of feet that there are. Now, the rectangle itself, as you can see, is 13 by 30. Now, if you have a rectangle which is 13 by 30, then the diagonal lines of that type of a rectangle run at 23.4 degrees, and that is the axial tilt of the Earth. So this is why you have this possibility of the north wall and the south wall at the top and the bottom of where we're looking as coinciding with the tropics of Cancer and Capricorn, if we draw a circle around the entire rectangle. In the last session, I talked about these measurement units, and I talked about them in relation to that diagram of the Earth and the Moon with the pyramid triangle. Now, it was actually the cubit that I talked about in relation to that. But I also mentioned these three different foot units. So what you're looking at here, these sticks with lines on, they're images of, I suppose you could say, measuring rods or foot units in relation to one another. Now, as you can see, they're all slightly different lengths. The medium one, the one in the middle here, is the English foot, as we now call it. And then there's another foot which is a bit bigger and another one which is a bit smaller. Now, the differences in these foot units give musical ratios, and I'll describe that now because that's something you possibly come across before. But this is something that's very much, I suppose, within the studies of the 12th century Europe. The study of musical ratios as one of the so-called seven liberal arts. Now, these divisions along the rods, there's 56 of them in that larger foot, 52 and a half in the middle rod, which is the English foot, and 50 micro units in the smaller foot. Now, what I showed last time was the cubit, which has 90 micro units. Now, because we were looking at that last time, I'm not going to look at that one this time. So we're just going to look at these 3 foot units. Now we'll look at the musical ratio side of this now. So if we take the numbers 56 and 52 and a half, now if we divide both of them by 3 and a half, then we end up 56 reduces down into 16, whereas 52 and a half reduces down into 15. And so we have 16 to 15, and that's actually the relationship of these two units. If this one is 16 units long, this one is 15 units long. Now, this ratio, if understood as a musical ratio, is a semitone. It's what's known as a just diatonic semitone. So there's the first musical ratio. Right, if we look at the medium-sized rod and the smaller one, and this time we need to divide both of them by 2.5. So 52 and a half divided by 2.5 gives us 21. And when 50 is divided by 2.5, we get 20. So the ratio here is 21 to 20. Now, this is actually another type of semitone. It's from a different type of tuning, what would be called septimal tuning. So it's a 7-limit tuning. Now, I won't go any further with that because it gets quite complicated. But in short, this ratio is called a septimal chromatic semitone. So the difference between these measuring rods, in both cases, is a semitone. So as any musician knows, 2 semitones make a tone. So the relationship between this larger foot and the smaller foot is 1 tone because there's 2 semitones between them, 2 different semitones, albeit. Right, so as you can see, I've put the nave, the beginning part of the cathedral, I've turned the cathedral up vertically so that we can look at the nave. So we can look at the measurements of this area in relation to these foot units. Now, when you get into the nitty-gritty of the measurements in the cathedral, there's actually 2 different geometric grids that are used in the one area. Now, this happens all over the cathedral. There's more than 1 grid in each area. Now, these different grids, they aren't sort of random or unconnected. They actually create even more interesting relationships within the design of the cathedral, more ratios in terms of their difference. And this is what we're going to see with these 2 different grids that are in the nave. And they create this, I suppose you could say, earthly ratio. Right, here we are back to the units again. Now, we can look at the musical ratios and we can look at how we actually work our way to that micro unit that I was talking about, that all of the units are divided up into. So there is the English foot, the medium-sized one. Now, if we divide the larger foot up into 16 units, and then we take one of those units off You see how the English foot is 15, so hence you have the 16 to 15. Now, if we do the equivalent thing with the English foot and the smaller foot, then you end up with the 21 to 20 relationship. Now, I'm going to put both of these measurements in at the same time, but then I'll take most of what's there out. So we just have 1 unit from each of those relationships. And what you end up with there, that red area there, the difference between those 2 units, that is the micro unit. So that's how you actually get this particular atomic unit, you could say, of the cathedral. Now, these 2 feet, the larger one and the smaller one, these are the 2 foot, the 2 feet, which are used, well, one of them in one grid, one in the other grid. So you have this interaction of 2 different grids, which each using a different foot unit. But as I mentioned, those 2 feet, they have a relationship of a musical tone. So with this grid that I'm going to describe as the red grid, one of the 2 grids, this is the one that has the 13 by 30 measurement. Now, obviously, the amount of feet is going to be more than that, but I'll show you how that happens shortly. Now, these lines which are running through the rectangle here, they denote the bay. So you have pillars in these areas here where the lines cross. That's where the pillars are, and then you have a rectangular area known as a bay, and the bay could be looked upon as being 7 units to 3 if the whole rectangle is 30 by 13. Now, this in my book, The Cosmos in Stone, this gives us these 2 different ratios, which can give us the axial tilt of Earth, 7 by 3 and 30 by 13. So this rectangle here, 30 by 13, is very similar to one that's 7 by 3, because they both give very, very similar diagonal angles. Now, this is actually, I've taken this in my book from Robin Heath's work. This is Robin Heath's book, Sun, Moon, Earth. So as you can see, with the 7 by 3 triangle, the hypotenuse gives this angle of 23.2 degrees, whereas when we have a 30 by 13 rectangular relationship, the diagonal, as it were, would be 23.4 degrees. So both of these equator ecliptic relationships are found within the nave, this first grid here that we're looking at. So you have the 30 by 13 and the 7 by 3. Now what we need to do is to multiply all of these numbers by 5, and that's what gives us the actual footage that we're looking at. So that length of 13 becomes 65 feet. The edge of 30 is 150 feet, and this is the larger of the 3-foot units that I was showing you before, the one made up of 56 micro units. Now the 7 becomes 35 feet, and the 3 measurements become 15 feet. So that's the first grid that we're looking at here, and that one can be identified within the nave. Now the other one, which uses the other different foot units, that uses a foot unit that's made up of 50 micro units. Its width is 73 of those feet. The long length is 168 of the feet. And then the bay part is 39 of those feet. And then 17, as you can see, along those other lines. And then the width of the bay is 16.8 of the feet. Now, these 2 grids are overlaid, and they're very slightly different in their width. And this is where we find the earthly ratio within the design. So we've got 73 feet in this distance here, and the foot units that's used is the 50 microunit foot. Whereas in this one, we have 65 feet, and the foot that's used is the 56 microunit foot. So we can put these numbers together, and we can find the amount of microunits that there are in these two distances, because they're slightly different. So 73 of that 50 microunit foot, 73 times 50 gives 3,650 microunits. Whereas the 65 foot distance here, 65 times 56 microunits, that equals 3,640 units. Now, if we take a look at those two numbers, which are slightly different, 3650 to 3640, as you can probably see, we have a significant earthly number, 365 to 364. Now, this is the difference in the width of those two grids. Now, the thing that I'll show in another talk at some point is how these two grids actually interact with the forms within the nave. So it's the positioning of the pillars which actually determines the fact that these two different grids are present, but I'll show that on another occasion. So this 365th of difference that you have between the two grids is expressive of these two significant numbers that we have with the equator and the ecliptic in relation to Earth. 1 year, which is divided up into 365 days. Now, Earth goes around the sun on this, what's called the ecliptic plane, and there is, of course, the equatorial plane. So in the amount of time it takes for Earth to go around the sun once on the ecliptic plane, the equatorial plane will have revolved approximately 365 times. Now, this relationship here, this 23.4 degrees, to be accurate, is what we have within the nave in the cathedral here in Wells. So there you have that diagonal angle of 23.4 degrees, which is what we find in the design of the nave in the cathedral. And using this ratio, which is also expressive of the relationship of equator and ecliptic, which gives 1/365th. Now, this more complex numbersy sort of work in my book, I only published a small amount of it in the book, and that's really what I've just shown you. That's chapter 13. But chapters 14 to 17, they're in a PDF, which is now available on my new website, tonburygeometry.com. So do take a look at that. And you can see how this micro unit and the foot units are used throughout the whole cathedral. Right, I shall de-share my screen and let's start drawing. Now, thanks for joining me. I took a bit of a while to wake up at the very beginning there. Wasn't sure if I'd actually pressed record or whether I'd unmuted myself. So I assume you can hear me. Right, let's get started. I shall switch my camera on to say hello. Hello, everyone. I shall spotlight. Right, I'm feeling a bit more awake now. I had a couple of hours sleep just before I got started. So thanks for coming. Thanks for joining me, especially those in my time zone. But thanks for coming wherever you are. Now, because I'm talking about Earth, I'm going to show a very simple bit of geometry, which I suppose it gives us a square and also the number 4, which are these two things that we associate with the four corners of the Earth. Earth has this association with the number 4 in lots of different traditions, interestingly. Now, I'll do a few sort of simpler diagrams on this side, but the main bit of work that we'll do is on this side here on the left. Now, I'll begin by setting the radial measurement of my compasses at 3 inches. So set your compasses to that. Right, um I'm going to do a mark that's halfway down the page between the top and the bottom. As you can see, I've got my page in landscape orientation, a piece of A3 paper. I'm going to get the halfway point because I'm going to put a horizon line on paper. So I've put a mark here. The paper is almost, but not quite 12 inches in height. So I'm just going to go to 6 inches. That should be fine. From here, down here, 6 inches. And I'll make another mark again here. Again, 6 inches down the paper. Now this should be enough. Just having a line like this. This area, we'll just do a few sort of simpler diagrams in. Now, the Pythagoreans, the spiritual community that were gathered under the mathematical mystic Pythagoras, they swore an oath over two different geometric forms. Now, the more commonly known one is what's known or what's called the tetractys. Now, the tetractys is um, a triangle made up of 10 points, which, as you can see, I'm doing here. So the tetra in the tetractys is because there's 4 levels: 1, 2, 3, 4, and 1 plus 2 plus 3 plus 4 is 10. Now, this was the main form that the Pythagoreans swore an oath over. But the other form that they swore an oath over was a 4 square. So let's take this to be the top of it. 1, 2, 3, 4. Now I'm putting these two forms together, but they're two distinct forms, but they happen to go rather nicely together. Because the tetractys, one of the things that it symbolizes is the descent from the one to materiality, which is understood as being fourfold. And so when you get to the earthly fourfold materiality, then you have this 4 square, as it were. Now we're going to draw a square that's 4 by 4. It's really, really simple to do. And then I want to point out a particular characteristic that it has, which is possibly why the Pythagoreans valued it so highly. Right, what I've done here, I've gone in at the 5 inch mark from the edge of the page with my 3 inch radial measurement on the ruler. Right, so having put that circle in, as you can see, I'm going into the right hand side of it. With the mark. In fact, actually, no, I'm going to do it differently. I'm going to put something straight in. One sec, bear with me. Now, this particular configuration that we're doing here, I often refer to as 3 moons, because we have the waxing crescent, the waning crescent, and the full moon. Now, using these 2 points here, I'm going to get a bisector cross above the circle. And then I'm going to do the same below. Now, what this does is essentially give us the middle path between, let's say, east and west, which is, of course, the north-south axis. So having put in these two crosses, I'm going to now put in vertical axis like so. Right, now we have these 2 points. I'm going to do something similar. Now, the tips of the petals, make sure that you've got your petals long enough, or the lines of the petals long enough, so that you have the tips of the petals. And as you can see, I'm using them to create a square that contains all of what we've drawn so far. Now, we've pretty much done the diagram. It's so simple, this one. So as you can probably see, between, I mean, we already have, I suppose, the square divided up into 4 squares. But the way to have 1, 2, 3, 4 along each edge is quite simply to, well, we take this form here known as the vesica. There's another one of them there. And draw the line straight through, like so. Now we can do the equivalent thing here as well with these vesica shapes. And this gives us the 4 square. So we now have this 4 square. 1, 2, 3, 4. Now there's a particular quality to this particular diagram, which you only find with a 4 square. So for instance, if you had a 3 by 3 square or a 5 by 5 square, you wouldn't have this particular quality, which is only in the 4 square. And that is that the peripheral measurement, so 1, 2, 3, 4 along each edge, so 4, 8, 12, 16 is the same as the area. Because of course the area, you've got 1 square, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the area, or the internal the internal part of the square is 16, but also the outer part is 16 as well in its length. So both the inner and the outer are in balance. They have this likeness to one another. And so the 4 square is significant in that respect. Now, I'll just do a few scribbled diagrams here. Let's say that we have a 3 by 3 square. 1, 2, 3 as the length of each edge. 3, 6, 9, 12. So 12 is the peripheral length, whereas 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the area. Now we could keep on going down with that. So let's say if we have just a 2 by 2 square, 2, 4, 6, 8, with an area of 4. And of course, if we just have a single square, 1, 2, 3, 4, and an area of 1. Now, if we went up to a 5 by 5 square, then it goes in the opposite direction. Let's see. My wobbly drawing. It is 3:30 in the morning. 1, 2, 3, 4, 5, 5, 10, 15, 20. Or 5 times 5 is 25. So as you can see, in these examples, if you go below 4, then it's the length of the edges which ends up being the larger number, and the area is the smaller number. But when you go beyond 4, it's the other way around. You end up with the length being the shorter number and the area being the larger number. But with the 4 by 4 square, everything is in balance. And so you have this other form that the Pythagoreans swore an oath over. I hope that that was an informative little exercise. I hope I made it coherent enough. If you're here in the UK, or if you can be in the UK at the end of September, I have a few places left on this course about the symbolism of the pentagram star. Now, this may end up in some form online at some point in the future. This one will be creating a labyrinth, hopefully just outside the west front of the cathedral, just waiting to get permission for that. And we'll do a wood parquetry pentagram in the form of Sir Gawaine's shield, the pentagram on his red shield from that Arthurian story, Sir Gawain and the Green Knight. And we'll look at how the pentagram shows itself within the design of the cathedral at Wells. I'll probably finish with that in the session, the final session that I do in 2 weeks' time for the new moon. I'll go into the pentagram a bit. Now, this class, this is an online class. There's a lot of people signed up for this one now, so there's just a few spaces left. In this one, we're looking at John Michel's mandalas from his book, How the World is Made. So do join me on that one. There's a few spaces left. That will be beginning on the 4th of October. So that's in a couple of weeks' time. So the final session, I've been doing these online sessions on the new moons and the full moons for almost a year now, or almost a lunar year. It'll be about 354 days when I get to this final session here, which is the day before my birthday as well. So that's a nice thing. I've spent my 52nd year doing these lunar sessions, which seems appropriate because, of course, there's 52 weeks in a year. So this is going to be the final one. If you're in my time zone, it's a much more reasonable time than the past two have been, 7:30 in the evening. Should be okay for a lot of people, I think, wherever you are in the world. So do join me for that one, because that's the last one that I'm going to do. I am going to continue to do, obviously, online courses, but more sort of standard paid online courses with pattern making. But who knows, I might do the odd one of these sessions beyond the final one in 2 weeks' time as well. But thanks for joining me at this one, and do join me for that final one in 2 weeks from now. So I shall switch on my camera to say goodbye. Thank you very much for coming, everyone, and do come in 2 weeks' time. Thanks for coming to this one. See you then. Bye.